Okay, this is going to be our last video, I'm certainly hoping. We're going to look at page 400, number 31, ESP. Scientists wish to test the mind-reading ability of a person who claims to have ESP. They use 5 cards with different and distinctive symbols: square, circle, triangle, line, squiggle. Someone picks a card at random and thinks about the symbol. The mind reader, quotes, air quotes, the mind reader must correctly identify which symbol was on the card. If the test consists of 100 trials, how many would this person need to get right in order to convince you that ESP might actually exist? Explain. Okay, now, what it's not saying here, but we need to think, is what we're going to do is we're going to treat this as normal model. Because what we want to do is we want to find the probability that you are going to be significantly different from totally guessing. That would make you think. If you're significantly different from a total guess, that would make you think that this person has ESP. We don't expect this person to get 100%, but what we need is we need them to be significantly different from guessing. Okay, so there are 5 cards. Okay, now with those 5 cards, if someone were to just guess at what a card was that I pick up randomly, the probability that they're going to have success is going to be 1 out of 5, or 0.2. So here's what we need to do. We need to find the expected value for this probability. And expected value, again, is n times p. And n is, we've got 100 cards. How many would we expect them to get right just from guessing? Times 0.2 is 20. Okay? Now, how far do we need to be from that so that there is a significant difference from them guessing? And what would be a significant difference? Or what would be an outlier? Anything beyond 3 standard deviations. That would be a significant outlier. Okay, so what's a standard deviation? Standard deviation is n times p times 1 minus p, which is 100 times 0.2 times 0.8, square root to phi. So let's find that. Second square root 100 times that's a 0, times 0.2 times 0.8 equals, standard deviation is 4, okay? So our standard deviation is 4, coming back to this. I hate when that just disappears. Let's bring it back. So our standard deviation is 4. So I think about this, we're going to set this up as a normal model. Here's my mean, here's my standard deviation. So I could think about it like this. Matter of fact, let's make a normal model. Here, let's do the 68, 95, 99.7 rule. Here's my mean of 20. I would go 4 in each direction for 1 standard deviation. So that would be 24. Going 4 in the other direction would be 16. What percent of the data do I expect to lie between -1 and +1 standard deviations? 68%. What percent of the data do I expect to lie between 2 standard deviations from the mean? Well, 2 would be 28 and 12. And I would expect that to be 95% of the data. Okay, and what percent? 3 standard deviations, 32 down to 8. And I would expect that, as I'm crossing over that number there, to be 99%. 99.7. Whoosh! I almost messed that up. 99.7% of the data. 99.7% of the data. Okay, so how far do we need to go to be an outlier? Well, I would need to go 3 standard deviations above the mean to this value right here. So how many cards would I expect them to have to get to show me that they've got some ESP? They would have to get at least 32 cards, right? Now, you know, we all sit there and say, oh, if they've got ESP, they should get them all right. Well, you know what? No one gets everything right. I mean, it's just the way it is. But they would need to be significantly different from just guessing. And what would be significantly different? 3 standard deviations. So this question right here, when it talks about that significant difference, you can think, oh, we've got a normal model, and that's what we're looking for. We're looking to use a normal model so we can find 3 standard deviations. The question might also sit there and say, use a normal approximation for this. If it says use a normal approximation for this, then you should be thinking along these lines and along z is equal to x sub I minus the mean over the standard deviation. Okay? And here's the very last thing that we need to talk about, and we'll bring this up, is that if we ask you for the information about a binomial distribution, remember that a normal distribution had these two pieces of information, these two parameters, mean and standard deviation. Binomial distribution had n and p, where n is the sample size and p is the probability of success. Okay, so that should do it, I think, for chapter 17. And of course, we've got practice test and then tests next. Woohoo! Yay!